small test over the first part of Chapter 5. Because Chapter 5 in its entirety could be long and tedious, we're going to kind of split it in two pieces. So we're not going to spend quite as much time reviewing for this chapter test as normal because it's only 3 sections. And then after that, we'll finish Chapter 5 and do another little test on Chapter 5. So I'll show you the schedule in just a second. So this says to solve for x by rewriting exponentials as logarithms and logarithms as exponentials. Now on that first one, did you have to rewrite? No. What was the answer and how do you know? How do you know? Because 4 squared is 2. Could you envision one of those problems that you couldn't do by hand? You could think of something, maybe it's 4 to what power equals 17. That would be more problematic, right? We'll talk about that one in a second. Okay, so 7 to what power is 149? Well, what power goes there? -2. How do you know it's -2? Because a negative exponent flips the fraction and the 2 squares it. Now, how many of you this one was tougher for you? Okay. Maybe you couldn't do it in your head. Maybe you could. That's where logarithms come in handy. Could you rewrite this as a logarithm? What would it look like? Log base 7. Can you type this in your calculator? No. What does it tell you? -2. So we have options. We can do things by hand if we can see it. If we can't see it, we can do it in the calculator. This is what we're going to be focusing on today. Okay, I want to solve the next one for x. Well, how would you do that? Take out the logarithm by doing a rewrite. The circle thing is nice. 10 to the -1 equals x. What is 10 to the -1? By doing the rewrite, by changing the logarithm into exponential format. Where do you hear that, David? Have you watched that video yet? I started, but I was going to. Okay, so there are 3 types of equations that involve exponentials and logarithms that you will see. There's equations that start out as exponentials. There's equations that start out as a logarithm equals a number, and then there's equations that start out as a logarithm equals a logarithm. And so we're going to talk about how to solve each individual case. We're going to use the exponential to logarithm and logarithm to exponential conversion all day today. So if you don't remember what that is, on your paper, right? Log base 5 equals x is the same as b to the x equals y. Remember, the little circle thing can help you get there, or you can just do it piece by piece. That's up to you. We have a lot more to learn with logarithms, and the equations can definitely get more complex. But today we're going to focus on the basic 3 types. Eventually, we'll always want to make an exponential or logarithmic equation fit one of these 3 types. So, to solve an exponential equation, you're going to want to use a logarithm. To solve a logarithmic equation, we're going to want to use an exponential. And there's 2 ways to think about it. I'm going to show you both options. You can pick your favorite way. One of them is just memorizing a rewrite, and one of them is using the inverse property of exponentials and logarithms. They both work great. So you have kind of two thought processes. I'm going to start with what you already know and use the rewrite. First of all, 2 to what power equals 27? Why can I not do that without a rewrite? 27 is not a power of 2, right? It's not an even power of 2. So it's going to be a decimal. I do know my answer is going to be somewhere between, well, let's think about it, 2 to the 4th is 16, and 2 to the 5th is 32, right? So it's somewhere between those two numbers. It's a decimal between 2 and 3. So the first option is to just do what we did yesterday, the day before, and rewrite this as an exponential. A lot of you, this will be your favorite option. Remember, I'm going to show you 2 ways. Pick one, love it, stick with it. You don't have to use both. I just need to show you 2 options. Some of your brains work different than others. Like you said, you get to pick your favorite. What is the rewrite to a logarithm? Log base 2 of 27 equals x. Can I find that number in my calculator? Do that. Is that reasonable from what I said earlier? So the answer should be between 4 and 5. That's definitely between 4 and 5. That can't be written as a fraction. I stopped at 0.75 because she did, but it's actually in the calculator a decimal that keeps going on, so you can't write it as a fraction. If it wanted it in exact format, like a multiple choice, then you'd leave it as log base 2. Everyone know where the log base button is? Remember where that is? Good. Skylar, you know where it is. Okay. Option number 2, same equation. Some of you will prefer to stick with the way you've always solved equations by doing something to both sides of it. So I want to teach you that option as well. You can choose again. I don't care which way you do it. As long as you do it correctly, I'm happy. So think back to solving equations. When something is added, how do you undo that to get it by itself? You subtract. Why do you subtract? Because they cancel. They undo. They're inverses. Who said that word? Was that you, Jessica? They're inverse operations. They cancel. If I have a square, I do what? Square root, because it's the inverse, right? What is the inverse of 2 to the x? Say that louder, Caitlin. Isn't log base 2 defined to be the inverse of 2 to the x? Isn't that what we said log base 2 meant? So if you want to solve this by doing something to both sides, you can. The thing you would do to both sides is do log base 2 of both sides. Log base 2 of 2 to the x just cancels and gives you x. And you're left with log base 2 times 2. It's right back where we were when we did the little rewrite. That makes no difference which way you do it. Some of you prefer the idea of sticking with one thing for solving, and that's doing something to both sides. This is the option for that. A lot of you, the rewrite is easier, so do that. I don't care which way you do it. You got both options. Any questions about the second option, how it works? Do you see how you get the exact same thing? Log base 2 27, either way. Okay, let's do the next one. Logarithm equals a number. Again, I'm going to show you both options. I'm going to show you the solving option and the rewrite option. Do you have to know both ways? No. Sometimes you do have to know more than one way, but for this, it's which way your brain likes it better. Pick one. Do that. Okay, so option 1. Okay, the rewrite. Some of you could do this without my help, right? What is the rewrite? 4 to the third equals x. This is what you do when you have a logarithm equals a number. You can rewrite it as an exponential. Do you see how either way we're using the inverse property of exponentials and logarithms? Really, we're doing the same thing, just in a different way. 4 cubed is 64, is that right? Option 2. Some of you want something to do to both sides to do an undo type thing. Well, what is the inverse of log base 4? 4 to the x, right? 4 to the power. So I can put 4 to both sides of the equation. 4 to the log base 4 cancels. I get 4 equals x. Land in the same place, whatever way you like. I imagine most of you prefer the rewrite at this point just because it's familiarity. But you can put everything. Any questions about either one of those? Okay, the last one is a logarithm equals a logarithm. For this to work, they do have to be the same base. Notice these are both base 2. If log base 2 of 4x minus 12 equals log base 2 of 3x, what has to happen? The insides have to be the same, right? Those are going to be equal. So option 1, just ignore the logarithms, right? Because if those two logarithms are equal, they have the same base, then 4x minus 12 would have to equal 3x. If you really want to see a solving principle behind it, to undo a logarithm, you would raise both sides to 2. Those would both cancel. And so we get 4x minus 12 equals 3x. But for all practical purposes, we could logic through that without doing that step. Does everyone agree with that? Those two logarithms are equal. The insides have to be. So anytime you have a logarithm equals a logarithm, they do have to be the same base, but ignore the logarithms and set the insides. If they are not the same base, it will probably become a calculator problem, which we'll talk about in a second. Okay, now what do I do? Okay, subtract 4x. And what do I get? And so what would x be? On a logarithmic equation, and I should have said this on the last one, we do need to check all of our answers. We could get extraneous solutions just like we could with square root equations. What can you not plug into a logarithm? We learned a couple days ago there's a couple things we can't put in a logarithm. Our calculator will say error if we try. Can't put in negatives. Can't put in 0. So if my answer makes the inside of either one of those negative or 0, I would have to say no, that's not an answer. So be careful about that. If I plug in 12, do either one of those logarithms become negative or 0? No, we're good, no problem, but always. Okay, so this is the lesson for today. We're going to do a couple more examples, but this is the gist. Any questions? A quick class vote. How many of you all like option 1 better? Okay, how many of you prefer option 2? I'll try to show a little bit about this. Alright. So equals a number. Look at the first one. What kind of messes it up from the beginning? The numbers in front, the 1,000, everyone see the 1,000? There wasn't one of those on the other problem, was there? So how do I get rid of it? Divide by it. So, what this slide, first we need to talk about is, the last slide is how you solve the basic format of the 3. We may have to do a little work to get it into one of those basic formats. So, I'm going to divide by 1,000. Everyone agree? If I divide by 1,000, I get 2 equals e to the 0.05t. Does that look a little better as far as being like the last one? A lot better. Could I now rewrite that as a logarithm? So for the 27 of you who raised your hands, this is a place where I can rewrite it. So let's do that. What's the base? E. So this is log base E of what? 2 equals 0.05 t. Have I gotten t by itself yet? Almost. What's the last step? That we said to divide by 0.05. Divide log base E of 2 by 0.05. So divide by 0.05. What is log base E the same as? ln. Good. ln of 2 divided by 0.05 is your t. I can now type that in the calculator. Someone do that for me. Why do you do that? Log base E and ln are the same thing. Yes, ln at the very beginning. You will get to where you do ln at the very beginning for people like Lily who didn't remember that or haven't seen it yet. It's why I didn't go straight to it. 1.386. Okay, and just for Braden and Lily, you didn't get 1.386.
Yep, 2.86.
Is that what you got? Or did you divide by 0.5 instead of 0.05? 13.86. My guess is 0.5 instead of 0.05. Okay, for Brett and Lily. Either way, you have to divide by 1,000. And then what is the inverse of e to the x? Isn't it log base e or natural log? So at this point, those of you who like the undoing process, you would take the natural log of both sides. So you get natural log of 2, the natural log of e cancel, and you have 0.05t. And you divide by the 0.05, you land in the same place. Those of you who prefer the other option, there it is. Questions about that one? What's the next one? Remember, I need it to be something to a power equals a number. That's the way I know how to solve these, is when I get something to a power equals a number. So, what do I need to do on this? Subtract 5. Does everyone agree I need to subtract 5? Why do I need to subtract 5? Does that work? Good. It gets it where it's just 2 to the power equals a number. And I can either at this point rewrite or take log base 2 on both sides. I'm going to quit showing both. Is that okay? Oh, you like the first one. So you change mine. And you either way. So I'm going to do, what is the rewrite? you know that? Anything to the 0 power is 1, right? So log of 1 is always 0. So what is x? Now, he didn't pick his calculator up to get that, but it mean you did it wrong if you did pick your calculator up to get that? So that's fine. It'll tell you 0 also. 3 is x. So 2 to the 3 minus 3 is 2 to the 0 power. It means 0 power is 1. 1 plus 5 is 6. You did a good job. Don't forget you can check your answer on anything by plugging it in. And one more like this. What would we do? Divide by 4 first. Remember, I have to have the exponent by itself before I can do a rewrite or take the logarithm of both sides. Now what? Now I can rewrite it or take natural log of both sides, whichever works for you. Which is natural log of 1/2. For typing it in purposes, the natural log. Go faster. Because there's a button. Natural log button. You'll know where the natural log button is? Left hand side of your calculator. See that LN? Any questions about that one? Okay, let's do a couple logarithmic examples. Same thought process. Double logarithms. Before I start, just like with exponentials, just like with square root equations, or any other equation I wanted to come up with, what do I need to do first? Divide. Does everyone agree?
Yeah.
I need that logarithm by itself to be able to solve the logarithmic equation. So divide. So I get log base 3 of x plus 2 equals what? 5. And now what? Do I have a logarithm equals a number, like that second case? So I can rewrite it, or use 3 to the x on both sides. So I get 3 to the 5th power equals x plus 2. And good, 3 to the 5th, 2 7, it's 243. That was a calculator answer, I'm sure. Now you could do it in your head, but that's time when, remember, your head is great, the calculator is great, best when used together. 3 to the 5th, I pick it up. Subtract 2. X is 241. Go ahead and plug it in, and I don't mean you have to do some big long thought process here, but what do I want to plug it in and make sure of? That I don't get 0 or negative in that logarithm. Wouldn't hurt to just go ahead and plug the whole thing in your calculator, make sure you get 25, so you know if you did a good job or not. Any questions about that one? On the next one, do I already have a logarithm equals a number? I do. So what do I do? Just rewrite it. Uh-oh. What's the base? E. How do you know it's E? Because it's natural log. Remember, anytime you see natural log, you want to write in a little E there to remind yourself that natural log is log base E. So now I can rewrite it as E cubed equals x minus 2. E cubed is going to be a decimal. You can type it in now, or you can add the 2 over first. It doesn't matter. But how do I get x by itself? E cubed plus 2 equals x. And that's a decimal that's 7 ones. questions about that? This one? Did you do 5 3 raised to the 5th or 3 times 5? Maybe 3 times 5. You did do it. Did you? Like you went to the... Yeah, you listed X and X.
Oh.
But okay. This one's just a strange one. How would I do this one? It's not necessarily like models, but yeah, just rewrite it in exponential format. What would you get if you do that? Can I solve that for X? How? Cube root both sides. Why cube root? Because it undoes X cubed. So just brought in an old equation type. We might do some more examples. Before we do more examples, I'll tell you what your homework is. 5.3A worksheet I thought was a little long, so I shortened it for you. So today's worksheet, we're doing the evens plus number 27. There are 27 of them, so that puts you at around 14 problems. Tomorrow you're going to get another, it's the same stuff tomorrow, we're just going to do more examples and get a little better at solving some that are a little tougher. We are going to also pick up the calculator tomorrow. Notice I didn't pick it up today except for numbers, but could we solve logarithmic equations in the calculator? There's no reason we couldn't, right? We can solve everything else in the calculator. Why couldn't we solve logarithms in the calculator? So if you get stuck tonight, you might try that. But it's one side by one and one side by one. So we'll do that tomorrow. On Wednesday, we're going to have a little quiz over exponentials and logarithms. Not a test, just a quiz. I'm going to grade that to you and get it back to you on Thursday so that you kind of get some feedback. It's really going to be part of your review assignment, and then you're going to also get a review assignment that day. And then on Friday, we're going to have a test. It is over a condensed amount of material. It's only over 3 sections, so it's not a big test. Kind of gets us a test in before we get overwhelmed with lots of material. Hopefully a good first test grade in this class. The other one, get a worksheet. So this is the weekly plan. That's what we're doing every day. So we only have one more day to learn, and it's really what we did today, just more complex examples. So evens plus number 27 on this one. Number 26 and 27 will be a little strange. They'll have letters in them. Any questions about that plan for the week? Quiz on Wednesday, test on Friday. If you don't have it, I'll get it to you. If you want it, if you have it, it's 14 tonight, then you'll get those tomorrow. Wednesday, I'll also give you a review assignment. Wednesday night, you start to review everything too. Really quick, 2 examples for you I want to do. One's with letters in them. Look at number 4. Yeah, 5 minutes. We could probably get both. as a logarithm, what would it be? And then what would x be? What I get x by itself. Okay, so that's weird, but is there any difference in the process? So there's one with logarithms with all letters, or exponentials with all letters. This one says log base A of bx equals c. So how could I get x by itself? This one is a logarithm, so how could I change that to be something different? Do this circle thing. A to the c equals bx. And you're right, they really should have put parentheses around that to let you know. And then last step, divide by b. So that's how you work those if those show up. Maybe 26 and 27. They're different letters, but similar.